Hey everyone, I'm James. I hope you've been enjoying the conference as much as I have. And my talk to you today is going to be on how to use God mode in Windows. It's a bit of a story about a research task that I got given during my day-to-day job at Trenchant, and I hope that you find it interesting. Let's get in. So I want to start off with a little bit of an overview. Specifically, I want to tell you before what you can expect to get from this talk. So this is going to be assuming that you already have RCE in a lockdown process and some read-write primitives of the kernel. That's what I refer to as God mode. And it's a story about how you can elevate privileges from that lockdown process. But to be able to do that, we're going to need to go over some basics here. So I'm going to give you some information on how access tokens and security descriptors work, followed by a history of techniques that have been used in the past on Windows 10 and Windows 11. Then I'm going to detail novel restricted token bypass, introduce another mitigation specific to AppContainer processes, and then it wouldn't be a good talk without also bypassing that too. But what this talk isn't is it's not O-Day, it's BYO O-Day, sorry everyone. Yeah. Wish it could be that, but we make do. And it's also not a bug or a vulnerability. As we already have read-write primitives in the kernel, this has already gone around the security model in Windows. And as you'll see from some of the history of previous techniques, Microsoft won't patch these. So I'm going to start with a little bit of an overview. This is very basic kind of stuff, just to give you some sort of perspective of what you want to do here. You're in a lockdown process. You've got your RCE and some read-write primitives. The first thing that you're going to want to do is open a handle to another process to be able to inject some payload and get out of this lockdown process, right? The first thing that you do is you call open process, virtual alloc to get some memory in there, write your process memory, write your payload into that process, give it execute permissions, and then start a thread. What is this? Access denied? What? When we call open process, we're getting error access denied, and we're not getting our handle. But we have God mode. Huh? Important. So let's start with what are access tokens? Well, access tokens define the security context of a process or a thread. And who cares about them? Well, the security reference monitor does. And that's the subsystem of Windows that when you request an object, it does the authorization part of it. Specifically the SE access check and the SE privilege check functions. Where can you find these? Well, every process and thread has one. And why do we care? It's because they detail what this thread or token should have access to from the object manager. So, excuse the wall of windbag output, but here I'm going to go over some details. So, the first squiggly line up the top, you can see it's S1532544, that's a SID. And it's in the user and groups array, and it has an attribute value, which is deny only. And also, we're going to go into this in detail, but just keep this in mind. And then down the bottom, you can see the second big squiggle. We've got restricted SID count of 1, and we've got a pointer to the array that has them. And in that, we have the no one SID. The green text on the right-hand side gives you a little bit of detail about that. So restricted tokens have a restricted SID, and that means that they're subject to 2 access checks. The primary one is to do with the user groups array, which is the top squiggle, and then specific to the restricted tokens is they also need to pass the secondary access check, which is specific to the restricted SIDs in that token. Alright, so that's the security context of the threader process that we're in currently. But what are we actually requesting, and what does that look like? So if this is a handle to a process or anything, it's called a DACL, which is a discretionary access control list. And this is what it looks like in WinBag as well. So from the top, I've given the command bang SD with a pointer to a DACL. It's telling me to a pointer to an object. It's telling me that the DACL is present for that object. And we can see a few things here that are of interest, which is the type of DACL is an access allowed ACE type on the squiggle. And yeah, so we've got one of them there is the system SID, and the other one is administrators. So this makes sense, right? The system SID and administrators should be able to access this process. So I'm going to go through some of the prior research that's been done. So back in 2011, Tajay Mant gave a talk at Black Hat where he talked about targeting a variable in the kthread struct, and it's called previous mode. So previous mode kind of tells the security reference monitor that the previous context that you're in was ring 0. So if you can change that, what it does is it just drops all further access checks and just goes, give this request, like give it a pass. And we think that it's because of a performance boost, but this has been around for a while in 2011, right? So it works on Windows 10, but it actually blue screens in Windows 11. Another example of a technique was a regression that was found in Google Chrome by James Forshaw, and it was a bug that broke the relationship between access token parents, childs, and siblings. And the thing with this, though, is that it required a bug in the Chrome GPU process, which has more privileges than a lockdown process, such as the renderer. And after the blog post, it was patched. Another blog post was done by Yarden Shafir on exploiting a simple vulnerability in 35 steps or less, where she details that SEDebug privilege gives you access to any process on the system, and that would hopefully raise some flags for a couple EDR products. So the technique there is to create a restricted token, manipulate the user and groups array so that it points to a high integrity SID, and then impersonate that. But sadly, from a lockdown process with the restricted token already, we're not able to call those APIs. So what can I do? Well, I crack open Ghidra, and I just start poking around. How easy could that be? How hard could that be? Turns out very hard. From that function graph, you can see that there's a bunch of different logic and stuff, and that's just for one function. I've detailed some more functions down the side, but in reality, the list just goes on and on and on and on and on. And there's no way that I could cover all this ground, right? But we have to take a second to think. Well, we've already got God mode. We've got some cheat codes here. So what if I could find the system process token and then change the token field in our thread struct to point to the system token? That actually works. Easy, game over, right? Well, turns out that's loud. Not quite that easy. This would just be an absolute red flag to any EDR or personal security product. Even if you look at it in System Informer, it says that this lockdown process now runs as NT-auth system and has a bunch of privileges and stuff that it shouldn't. Also, to rub more salt in the wound, this is actually old news. There was a blog post since I gave this talk the first time. I found a blog post that details this technique already. So this is me. After weeks of looking into all these different subsystems and functions, I'm just down and out for the count. I don't know what to do, but we persevere. So what does the solution look like? Well, first of all, I'm going to have to edit the attributes value given to a token's user and group SIDs. And secondly, and this is going to be the hard part, bypassing the secondary access checks specific to restricted tokens. But there's no research on this before, so we're going to have to figure that out along the way. Well, first things first, let's try enabling some SIDs. So every entry into the user and groups array contains An 8-byte pointer to a SID object, I don't really want to understand that. That's complicated. But there's also an unsigned long attributes value. And some of those values are pretty easy to enumerate. So hex 10 is deny only, and that's what we're seeing in our restricted SIDs. It's also specific to restricted tokens because other tokens can't attribute deny only values here. The other ones are enabled. All right, so let's go back to the token that we were looking at before. Here we can see that there's a bunch of SIDs there with attributes set to deny only, but we can enumerate that array and start changing them to be enabled using our read and write primitives or WinBag itself. Deny only SIDs are specifically very troublesome because if they match any SID that's in the object's DACL that you're going for, it'll cause any other access allowed kind of like things to just be over and just give you a deny. Well, that was only half our problem. The hardest part was the restricted token bypass. And this took me a considerable amount of time. I was reading a whole bunch of stuff about it, and nothing really was clicking for a long time. But let's have a look at what they look like in WinBag again. So we've got our restricted SID count, restricted SIDs, and these hashes in between, right? Well, that's going to be problematic. And another problem is that the restricted SID that is turned on is the no one SID, and that is devious work because there's no way that you could possibly get that to pass the secondary access checks because no DACL has that on. Sweet. And changing that value as well means nothing because we need to still pass the secondary access checks. And so we need this to match something in the object's DACL that we're going after. And I can't clobber the SIDS field or the restricted SIDs, the pointer to the array, or even the count, because there's these hashes afterwards that is checked, and it was just, I was spinning out. It was crazy. Yeah, so nulling everything didn't work. I also can't call any APIs to be able to change or create the token or of the thread or the process.
A few moments later.
Well, so you'd think, but really I was coming into work looking like this all the time. So, all right, we're going to go back to the basics. We're going to have a look at the SEAccess check function and its code flow. I spent a lot of time reading the Windows Internal 7th edition Holy Scriptures, but I couldn't find anything that would kind of like give me a clue. I wrote a Ghidra plugin to pass the disassembly and decompiler output to our local LLM, which was heating our Wellington office over winter. But then I looked at some other resources that were out there, such as ReactOS. For those that aren't aware, ReactOS is a FOSS alternative to Windows that was created and maintained in part by Alex Enescu, who's a great researcher. I did check, in that source code, I was looking before the secondary access checks, even before the first access checks. But there was nothing new until I was looking at a random function and something caught my eye. As you can read there, it was sep access check and audit alarm with adminless checks. So there's just so many functions here to go through, but something here was really interesting. There was a function called se token is restricted. Okay, what does that do? Could be onto something here. So the ReactOS implementation, it checked the token's token flags and then did a bitwise AND with this token is restricted value. Well, what's that? Poking around some more, I see that there's a hash defined up the top, the first line here in this code snippet, which is token is restricted is hex 10. Okay, let's see what we can do here. You know, we're onto something. Going back here, sorry, the squiggle's kind of like rendered over the token flags field there, but you can see token flags, and it's actually got that hex 10 bit set. Well, what happens if we just flip that? Turns out that then it does none of the secondary access checks. We just got access granted. It was like that easy, really? Well, you'd think so, until another security mitigation was introduced into some of these lockdown processes, specific to
this guy stinks!
specific to AppContainer programs. So all modern Metro apps that you get through the Microsoft Store are actually AppContainer programs, and these have another access check, which is handled by a different process called the runtime broker. That means that they can further sandbox the process by denying access to syscalls, functions, and more. It was introduced in the Edge render at some point, and their access token has so many more fields. It's very complicated. I didn't even want to look at it. Here we go again. But I'd already spent a lot of time looking at the secondary access checks for restricted tokens. So what if there was something to do in the token flags that would tip us off that this was an AppContainer program, and what if we just flipped that as well? Turns out that was just what we needed. And like from the month that I'd spent before looking at restricted tokens, this was a mitigation that was by a lot of metrics far more complicated, but using that understanding meant that bypassing this mitigation was really easy. And if you guys, so in review, let's go over what we went over. So we learned a little bit about access tokens and security descriptors. We learned about the code flow for the SE access checks functions, and we went over two techniques to bypass some security mitigations. And what does this mean? It pretty much means that we can request a lot of things from the object manager that we shouldn't have been able to from the lockdown process. With the SIDs for admin and system turned on, you can pretty much get anything, almost anything. There are other things that are further locked down. Here's a bunch of research that I did, other people have done, and it's really the only reason that I was able to get through this. And last but not least, if this sounded like a cool kind of story that you'd be interested, then you should totally consider joining us. We've actually got a CTF hosted at CTF Trenchant.io on port LEAP, and if you get that solved, then please do reach out to recruiting@Trenchant.io or send your CV straight through anyway. We do some of the most interesting work on some of the hardest platforms that there are, and you work with really nice, fun, aspirational people. Not me, though. The others that help me. So I've also got Twitter. My Twitter handle is 3_bluescreen, and the company's is Trenchant AR. So with all that said, let's go to the pub.